Hi, one and all. This is Lohith Krishna of final year CSC from MBR College of Engineering and Technology. Today, I am going to explain and elaborate my project. My project is based on denial of service and distributed denial of service using software, cryptographic software puzzle. In this video, I am going to show and tell you about how my system works, abstract of my system, existing system and proposed system, pros and cons of existing system and proposed system of my project, followed by system architecture and design, and I will going to share some of the screenshots of my project, how it works, and finally conclude this section. So, denial of service and distributed denial of service are shortly known as DOS and DDoS. This DOS and DDoS are a major threat to cyber securities, and in this project, we are going to tell you how my DOS and DDoS will help us from inflating attackers from software puzzle and testing their software puzzle solving capabilities. Software puzzle. Denial of service and distributed denial of service are among major threats to cyber securities. Nowadays, each and everyone is using some or other device to connect to internet. Uh, connect to internet, in which cyber security is going to be a major threat. In this project, we are going to show how to prevent device and device attackers from creating software puzzle capabilities. To this end, we introduce a new client puzzle, which is also called as software puzzle. This this puzzle is different from another puzzles because we use RSA algorithms to decrypt and encrypt and decrypt, and the cryptographic puzzle, and you use cryptographic methods to prevent attackers from inflating their attacks. In this system, the present software puzzle scheme is randomly generated only after a client request is received at the server side, and the algorithm is generated such that an attacker is unable to prepare implementation to solve a puzzle in advance. The hacker needs the considerable effort in translating a central processing unit puzzle software to its functionality equivalent GPU, such as the translation cannot be done in real time, which means when the server has received a request from the client, it will send an algorithm in which our software puzzle will be there to the client, which has to be solved by the client. The server will consider only the client who solves the software puzzle. The software puzzle can be solved through clients based on client GPU version available at him. Moreover, attackers mostly fail to do this because they don't have the accurate GPU version of the client. Moreover, we should show how to implement software puzzle in generic server browse models, followed by existing system. DOS and DDoS are effective if intruder allocate a deal much few sources than the affected server, or a whole lot greater than effective than regular clients. That means DOS and DDoS will work most effectively in the cases where the attackers with low resources or with higher resources try to steal or try to attack our system. Then in that scenario, our system will work very effectively. The seriousness of DDoS and DOS problem and their increased frequency has led to the advent of numerous defense mechanisms and degraded services satisfactory due to highly priced cryptographic operations. This DOS and DDoS is going to help many serious issues like the defense mechanisms and degraded services. These are these are at the very highly priced peak point. So only these are usually in mainly very confidential matters. Present browsers such as Internet Explorer, Firefox, and Chrome does not explicitly support client puzzle schemes. Kaiser and Frank are the first persons to develop a web-based client puzzle scheme which focuses on transparency and backward compatibility. For incremental deployment, the scheme dynamically embeds client-specific challenges in web pages. Transparency delivers several challenges to the server and the client responses. This means the Kaiser and the Flame are the first persons to develop a puzzle scheme which is used to defend the server and client communication responses. And I forgot to tell you that our system is based on client and server communications. In this, we're going to secure the client and server responses only, followed by disadvantages of existing system. Puzzle is designed based on client's GPU capability. The GPU inflation device does not work at all. This means our system is mainly based on client's GPU availability only. If the client GPU has failed, then he cannot connect to the server for his the lifetime till the GPU is repaired. However, we do not recommend to do so because it is troublesome for massive development due to not all clients have GPU enabled devices, and an extra real-time environment shall be installed in order to run GPU kernel. This means, as we said in the earlier, that this is based on client GPU capability. So the clients with only GPU enabled devices can only use this device or DDoS attacks, and an extra real-time environment shall be installed. Means processing the GPU will not only directly help us in this puzzle solving capabilities, it should have to be working and is really connected to the kernel and the CPU. However, the scheme is vulnerable to device attacks who can implement the puzzle function in real time. If the attacker tries to attack in real time, if he tries to somehow manage the GPU capabilities of the client, then he can access our system server information and steal the available information. Existing systems are not dynamic. Presently, existing systems are not dynamic. Followed by prepared system. It adopts software protection technologies to ensure challenge data, confidentiality, and code security for an appropriate time period. That means it adopts a software protection technologies to ensure challenge data confidentiality and code security for an appropriate time period. Example, 1 or 2 seconds. I mean, it takes some or 1 or 2 seconds in which some of the attackers can attack. Followed by code protection, which focuses on long-term robustness against reverse engineering only. The software puzzle may be built upon a data puzzle. It can be integrated with any existing server-side data puzzle scheme and easily deployed as the present client puzzle schemes. The software puzzle will build upon that. This project presents a new type of client puzzle called software puzzle to defend against GPU-inflated device and DDoS attacks. In this, we are going to use cryptographic software puzzle, which is also known as client puzzle. Rather than the other. Followed by advantages of reported system. SLS and TLS server performs an expensive RSA decryption algorithm for each client connection request. Thus, it's vulnerable to device attacks. As I said earlier, in this we are using the utmost RSA decryption operations for each client connection request. Thus, it's vulnerable to device attacks. Means we are using this RSA algorithm to encrypt and decrypt our code software puzzle such that other than the server and the client, the remaining people cannot access through this device and DDoS user system. Our objective is to protect SLS by TLS server with software puzzle against computational device, particularly GPU inflected device attacks. The software puzzle dynamically generates a function. This is our system will randomly pick up the software puzzle, which is very dynamically and generates a puzzle functions. Followed by system design. Here we can see the system block diagram of our system, in which it has some of the words like W, KSN, puzzle 7x and 7x. This work will be going on at the server side, in which the W means the code block warehouse, which has CPU blocks of code of CPU and algorithm code. When the server receives a request from the client, then it will take the client sorry when it will send an algorithm to the puzzle generator, which generates a puzzle CYX when it is combined with the cryptographic keys like key SN. For example, here we take key SN as the cryptographic keys. When these are added with the puzzle CYX, the code production is active. Followed by we can finally get a software puzzle known as the puzzle C1X, followed by system architecture. Here we can see this is the server block, and another thing is the client block. In client block, we can see the host CPU and the GPU kernel. So when the client sends a request to the server will send a challenge X, which is our software puzzle, to the client. The client CPU will send that challenge X to the GPU kernel, in which the GPU kernel will solve the software puzzle, in which the solution Y from the GPU kernel is again forward to the host CPU. Then the CPU will forward the response XY, which is the X is the puzzle and Y is the solution of the puzzle. So this is whole response XY is the puzzle solved to the server, followed by implementation. In here we can see that when the sender receives a request for connection, he will send that sorry he will send that software puzzle, in which after solving that the connection will be stable. If not confirmed that if you cannot solve the puzzle, it will go back to the sender, and again the sender will send you another puzzle. Or if the sender will confirm that you are the original client, then it forward you to the server that you are the original client. Then the server will send the data in sense of packets, sending packets with puzzle to the receiver. If not solved, you are treated as an attacker. If solved, you will receive the data from the server. So as I said earlier, I will show you some screenshots of my project. Before explaining these screenshots, I will just give you an overview of my project. First of all, this device and DDoS, it is a client and server based application. So, and we just developed this application for the server side, not at the client side. As the server side only will be having the less amount, considerably less. Prices will be less considering with the server client communication, because in the server kind in a server and client communication, one server can be accessed through many clients. But if we do this on the client side, then we have to do this project for each and every client, which will cost us very long money, and it will take much more effects than the following. So let us go into screenshots. Here we can see the home page in which software puzzle a countermeasure to resource inflated and all service attacks puzzle generator. When the server receives a request from the client, then the server will send an algorithm to the client, which can be shown here. We can see that assign puzzle, split and send. When the server receives a request from the client, it will assign a puzzle. This is the middleware host which helps us in connecting the server with the client, and the server will have all the details regarding the client and can do whatever the server wants. Here we consider these receivers B, C, and D as clients to the server. Here, after the client puzzle is generated, the receiver have to enter the server have to enter the receiver IP address through which the receiver can connect to the server. And you can see here it's a path verification resource. Here, when the server and client are get connected, then they will send a puzzle. If the puzzle is solved, here we can get 1, else -1. If it is not, if the client is not responding, we will get 0. You can see this is at the server, receiver side. The receiver will get a pop-up like this. He has to enter his cryptographic key values called variable keys. After entering the correct keys, you can see the puzzle solved successfully and the file is accessing. This will all be happening at the receiver side. Following, when the receiver when the file is solved, the receiver will have this data coming from the server, and at the server we can see that the data is received to the client. Followed by, in this graph is based on a software puzzle environment measure to resource inflected denial of service attacks, which means we can see here in a graphical perspective, in a graphical view, that how many members try to attack our system. In this, receiver B has tried a lot to crack our system, but he cannot go through that. Followed by, this is the software puzzle environment resource inflected denial of service attacks, shortly puzzle solved users. Here you can see receiver B, C, and D cannot solve the puzzle through it, but the E can solve. Conclusion: this project, this project software puzzle scheme is proposed for defeating GPU inflated DOS cells to secure the data. We are using the software puzzle to protect the data from DOS attacks. It provides a long-term confidentiality and cannot access the server. If the user is not legitimate user, it returned as an assault or attacker simply. The puzzle is the server side and easily deployed in the client side. In this puzzle is generated at the server side. It consumes server time because of its server processing is slow. The problem is server, how to build the client side puzzle to decrease the server time for good access. I would like to thank my guide, our principal and head of computer science department, Mr. D. Srinivas Garu, who helped me in this project. And I would also like to thank my teammates, Harisha, Anusha, and Ashya, who helped me in this project. And I would also like to thank each and every individual who helped me to make this project this success. Thank you.